BBN.
So, hi everyone, my name is Richard Barnes from BBN. I'm actually a first-time NANOG attendee. I'm actually not an operator, I'm not a vendor. I'm kind of an odd duck here in some ways. Oh, hey Matthew. I hang out a lot in the IETF, so I'm talking today about some technology that's sort of emerging, some IETF stuff that's been emerging related to geolocation. And this actually kind of notches in really well, being the last talk, notches in kind of well with the first talk of the meeting that Dave Ward gave, talking about the possibility that exposing some information from networks, exposing that information out to applications could really enable some new stuff, create some transformative applications, enable some really good stuff, and improve the network overall. So with that, so I wanted to briefly review, what the world looks like today from a geolocation perspective. So we have this situation where there's all sorts of applications that want information about where the users of those applications are physically located. So this includes things like traditional location-based services like Foursquare, Yelp, what's the weather where I am, what are movie times where I am, show me some Chinese restaurants around where I am, typical location-based services. So those things fall into this bin. There's the thing that's been around for like a lot longer is things like content localization and advertising. Localization especially, if you think about people like Google and Yahoo need to decide, when I get a request for an IP address, do I serve them google.com or google.fr or google.de? So it's a very coarse, and it's not a visible form of geolocation in a lot of cases. It's not something where a user is explicitly saying, show me what's nearby me, but it's one where it's a critical one for a lot of content providers to make sure that the right content gets to the right users. There's also an increasing demand as valuable content gets revealed through things like Hulu, through iTunes, to control access to things based on where people are. So I want to open up my service to users in the US or in France and Germany, but not in Singapore or in Japan. There's also some emerging work in using location information for things like fraud mitigation. How do I detect when an online purchase made with a credit card is fraudulent or not? Maybe if there are speed of light constraints on being used in one place and then being used in another, we can use this at least as a heuristic in detecting when there's some fraud going on. So there's lots of applications here, ranging from advertising, this fairly static stuff about how we pick the right version of Google or Yahoo or Baidu for that matter, to present to people, ranging all the way out to the much more dynamic stuff like location-based social networking, restaurant recommendations, weather, things like that. And right now, these things are based on, as Dave put it on Monday, scavenged information. There's these over-the-top services that I'll talk about in just a minute that are kind of halfway work but have a lot of problems, and especially they cause some problems for an operator perspective that I'll talk about in just a second. And the hope that what I'm going to talk about today is that maybe if we create some interfaces from the network to allow operators to supply these applications with some information, we might be able to improve this situation. So if we look at how these services work today, they get location information from basically two sources. There are these third-party services that reside off of devices. They don't have any touch with the network at all. These have been around for many, many years. They go under the heading of IP geodatabases. So these are based on things like scraping information out of the Whois databases. If I register my contact information as being in Topeka, even if my network is in Dearborn, the Whois, people will grab that Whois and say, aha, you should get ads for Chinese restaurants in Topeka instead of in Michigan. So that has that failing. People are some of the more advanced services that do this stuff actually do network mapping. They do trace routes and things like that to try and infer topology and improve your estimates of location based on that. But obviously there's, given the divergences between topology and geography, there's some pitfalls there as well. And sometimes, in very limited cases, some of these services actually buy information from ISPs, and it's very limited and obviously can't cover much of the internet that way. So that's sort of the third-party view, and those tend to be, coarser grade. You can get sort of country or state or maybe metro area location out of those things with, 90, 95-ish% accuracy. And I'll talk a little bit more about that in just a second. The other class of location services we see are what I call first-party here. So if I've got an app that's actually running on a device that's connected to the network, it can get a little bit more information. So, we've got GPS things, obviously, where that works. So that works well in some cases. If I'm driving in a car in an open area, sometimes that works pretty well. But if I'm inside of a building or in lots of urban areas, it really doesn't. And so there's these Wi-Fi and cell databases that have shown up. If you look at Android devices or iPhone devices or Windows phone devices, BlackBerries, all of those have services where the device, the phone will listen to Wi-Fi access points and cell towers that are around it. Say, I can see these 5 access points and these 3 cell towers, and it'll send that off to some service on the other side of the network that has a database of access points and cell towers. It says, okay, so I think these things are in downtown Philadelphia, so you are somewhere in downtown Philadelphia. And so, like if you use the iOS Maps application, you'll see when you click the button that says, where am I? You'll see this rough circle appear, and that's the network-based thing. That's this, Wi-Fi cellular-based thing that will then tighten down, hopefully, to a GPS thing if it works. And then, of course, the very last thing you can do if you're an app on a device is just have the user say where they are. You can ask the user, where are you, and use that as a location option. And that, surprisingly enough, is how most 911 services operate for voice over IP. So if you look at, there was this mandate from the FCC a few years ago that voice over IP services had to provide 911 emergency calling in the US. And if you look at how that's actually implemented nowadays, it's mostly by just asking the user where they are, which, despite all the pitfalls, is the state of the art there right now. So, the state of the art across this is that the performance properties of this whole system, they're sort of good enough to get a lot of stuff done, but they kind of suck still. So if you look at these IPGeo databases, there's a whole lot of variability. CADA actually did a very good study last year comparing these databases, which showed, they had this variability from about a kilometer to sometimes many hundreds of kilometers, sometimes many thousands of kilometers in completely different countries. And there's a lot of dependence on what sort of network type you're in. So if you're in a DSL or fiber or cable network, they're pretty good, but they're much worse in mobile networks that tend to backhaul over longer distances to GGSNs. And a really important thing to try and tie this in with the rest of the morning is that these databases right now have little to no coverage of IPv6. There's a couple of databases that have some experimental support, but by and large, there is no generic IPGeo for IPv6. So this is a real failing. In the mobile space, in these first-party APIs, if you've got GPS and GPS works, then you're kind of in good shape. But the performance of these wireless databases, the cellular and Wi-Fi access point databases, is really an open question. Because they're based on the people who operate the databases going around and collecting the information. There's no central registry of Wi-Fi access points anywhere. So if you want to have a service based on Wi-Fi, you have to drive around, or you have to have your mobile phones, Android phones report information about access points they observe and things like that. And so this scavenged database that has obviously variable data quality, variable amounts of coverage. I'm actually working on a study of this, and what we expect to find is that in urban areas there's probably pretty good coverage, but if you get out into rural areas or developing nations, there's probably much less fidelity there. And if you look finally at fixed networks, so looking at this first-party perspective, if we're in the device, at fixed networks, they're pretty well covered by these IPGeo databases. But if you want any sort of greater fidelity than that, greater than this 1 kilometer precision like you would need for a 911 service, you really do need to ask the user. And of course, that gets stale very quickly if someone takes a device from one house to another, and you're sort of out of luck. So the question is, when things go wrong, how do we fix them? And right now, this is, emails to the NANOG mailing list seem to be the primary mechanism for this. In the IPGeo database context, there's if there's problems in the databases, obviously you need to detect them as an application provider and then go fix them on a database by database basis. So there's actually this wiki here that says here's how you go submit these web forms or send the right emails on a database by database basis, assuming you can detect what's going wrong and figure out which database it is that you've gone wrong in. And if the database you've gone wrong in happens to not be on that wiki page and no one has figured it out yet, we get these emails to the NANOG mailing list that scanning back through the archive show up, a couple times a month, on the order of 1 to 5 times a month. So it's kind of an awkward situation for operators that, you've got your users that are depending on these services They want to get the right version of Google, especially outside the US, where it's determining what language the content is delivered in much more frequently. They want to get Google or they want to get Yahoo in the right language. And when they don't, you get help desk calls at the ISP because Google doesn't work right for me here. Why is it in German instead of Dutch? And then when you try and go and fix this, you have to fish around and find the right place to stick it in. So the question is, can we find a better way to do this? So there's a couple of technologies that are emerging to do this. What we're hoping to provide here, and there's a couple of different avenues for this, is to provide some channel where the ISP who owns the physical infrastructure and knows where things are can provide some authoritative information up to these applications that want to know where things are. So, as on the previous slide, there's not really a channel for that information now. There's these individual per database web forms, email contacts, things like that. But there's not any sort of automated universal system that everyone can feed off of and that can be simple for people to operate, low cost in terms of the last presentation. And the upshot of this is that we see fairly frequent failures for the applications, fairly frequent failures that users see. And on the operator side, there's not really any way to fix this when you have an unhappy subscriber. So I want to briefly talk through a couple of different avenues for fixing this problem. I'll sort of go in order from worst to best. So the one that's been getting a little bit of press lately is this injection system. So there's a startup called Fiva, there's another one called Bearing Media. And what these guys are doing is they're building transparent HTTP proxies that you can put into routers. And so what happens with these is when a user sends an HTTP request out, the router, or the proxy that's sitting in the router, sees this HTTP request go through, and it talks to some infrastructure in the back end, talks to some ISP infrastructure, radius infrastructure, and says, hey, where is this IP address? And it gets back an encrypted result that can only be read by this demographics provider. And it sticks that encrypted result into an HTTP header that then gets conveyed to this web server of an advertiser, something like that. So this is kind of terrible in a couple of different dimensions. First of all, it only works for HTTP. So if I have a VoIP application or a 911 application that's trying to do its job using some protocol other than HTTP, this system doesn't do anything for it at all. And second, it's really awful from a privacy perspective. So I chair the GeoPriv working group, so I care a lot about geolocation and privacy. And if you look at this, it has a couple of really bad privacy properties. One, users have no idea when this is being done. If you look at what providers tend to do when they enable this sort of stuff, they will contact their users and say, hey, we are providing your location information to some people sometimes. Say if you want to turn this off, usually without specification of where it's going, when it's going there, and usually with only a binary option for users to turn things off to protect their privacy. And so there's this very limited privacy control channel there. And if I'm a user, I can't even detect when this is going on, right? So it only goes out in HTTP requests. I can't see it in the response that comes back to me. And even if I set up a test server, it's only being injected when it goes to specific advertisers that the provider is partnered with. And so it won't go to my test server. I can't see it. So it's sort of interesting as a proof of concept that there is a way that operators can provide information out to applications. But it's maybe not the long-range path in terms of having something that works for many applications and something that has a reasonable privacy story. So the second one that's a little bit better is this an effort that's going on in the GSMA community, in the mobile community, called One API. And what this is the suite of REST-based, HTTP-based, what they call network APIs that open up access to various network services for applications to take advantage of. So there's a geolocation API, there's an SMS API that allows you to send SMS messages over HTTP. There's a charging API that allows you to ask for money from a user. And one of the things that's nice about this is that in addition to being easy to program for because it's REST and JSON over HTTP, it actually has sort of an authorization story. So the IETF and some of the web community have been working on this OAuth thing as a way of providing delegated authorization. And so the whole idea of the OAuth system is that you've got a user that has some resource that he has control over. So in this case, I might be the user and Verizon as my wireless provider might be the one that holds that resource. And so OAuth provides a technology for me to automatically delegate access to that resource, so access to my location, to some app. And so I might say, hey Verizon, you should let Foursquare use my location through this API. So there is something of a privacy story developing here in terms of controlling that access via the user. The challenge here, if we were to sort of consider this, maybe this is a path toward something for the internet, is that there's still a little bit of technology missing. So the critical thing in terms of making it work is that there's not a way to find the right person to talk to for a given subscriber. So one of the overall themes here is that there's not really a single database that's good for every subscriber in the world, right? There's no single database, there's no one that knows about Verizon's users as well as Singtel's users, as well as Deutsche Telekom's users, as well as Armenian Telecom's users, right? So we need to figure out, if we want to make an application that's globally deployable, we need to discover for a given subscriber which database, which geolocation service I should talk to. And so this API is built more for a statically configured thing where I can look at, say, a telephone number and say, okay, that's a Verizon number, I'll go to Verizon service, I'll go to AT&T service for this number. So there's that challenge. There's also a few sort of GSM telephone specific things in the API itself that would need to be squared away if we were going to try and consider this for the internet. So in a third thread, there's been an effort in the IETF to create a system that can provide a geolocation service for the internet. Historically speaking, this came about because the IETF started looking at the problem of 911 for the internet. How do we take this VoIP system we've developed, this SIP protocol, and make it possible to do emergency calls with this, 911 calls, 112 calls. And it turns out that it's actually pretty easy to do that once you have geolocation information. And so the question arose then, how do we do geolocation information in a way that's highly reliable? It's much more reliable and much more authoritative than the current IP-geo regime that we live in today. So the idea is, we should have this system that's simple to wrap around existing location resources. So providers have databases of where things are. We should have something that they can wrap around that and provide a uniform standard interface to those things. We should have something that has internet scale properties so that we can dynamically discover which database to query for an IP address. And we should have an explicit consideration that takes into account privacy considerations and how users manage privacy. So this has been going for a few years. We're starting to have some mature technologies coming out of this. And the basic framework is to allow both end devices and third parties applications to discover the right location resources and then have a standard protocol to ask for that stuff. So the first step is to do this discovery thing. So the standard, the ideal way, in the ideal case, if you're talking DHCP out to your subscribers, you can provide a name to them that says, you should go look for your location server over here. And so you provide this name, example.com, and then the device can go out and look and say, aha, that is the URL for my location server. And if you're thinking about a 911 app or something, the 911 app can then go query that location server, get the location, and find out who it should be sending its 911 calls to. Likewise, Foursquare can query the location server and figure out where it should be checking in right now. So there's this is sort of the gold standard discovery mechanism. I'll mention a little later other mechanisms for handing out these URIs, because the overall protocol being an HTTP-based protocol, obviously all you need is a URL to get to it. The most obvious thing you can do is not stick this under some arbitrary domain name, but stick it under a reverse domain. And in that case, if we start from an IP address, whether it's the IP address of an end device or the IP address that I seek as a source IP address as a web service, say, then we can look in the reverse DNS tree for these records and find out location server URIs for remote services. So that's how we find the services. And once we have those URLs, we can talk to them. And so this is, I won't get into this in detail, but the idea is that if we're on a device, we can send up these measurements, cellular or Wi-Fi or DHCP information or DSL information if we've built this into some CPE. And we can get back information about the location of this device, either in geodetic form with coordinates or in the form of an address. And in this case, we've got the address down to my guest office in Cambridge in Building 5, Room 123. If we're a third party, if we've got some web app asking for location through this channel, right, you can send up identifiers for the device. We're not on the device, so we can't send up measurements, but we know what device we're talking to, so I can send an IP address in V4 or V6. I can say what port I saw this coming from, or if I'm some telephony-enabled service, I can even send up an MSI-SDN or an IMSI or something. And likewise, the response actually looks just the same, but what I'm trying to illustrate here a little bit is that one nice thing about this being a web service is that you can distinguish who's asking. And so as a location server, I can see, is this the device itself asking me, or is this somebody else? And I can make privacy decisions based on that distinction. So when the device itself is asking, I can provide very detailed information down to the room number, whereas here I might provide only the building, I might provide a little bit more uncertainty in that geodetic location. So that's the protocol. It's pretty simple. So there's also a privacy framework that goes along with this. I won't go into this in tremendous detail because we're getting short on time, but you can read RFC 6280, which provides a very detailed architecture for how you manage privacy rules around location stuff. But there's the really simple shortcut story through all this is that if you're running a location service, you can provide the user himself whatever he wants. And you can distinguish that based on what IP address you see a request from. And then you can provide something that's more general, it's fuzzier to any third parties that ask. And you can use that distinction as a very basic thing to help make some privacy preserving decisions. And so we've built all these things, and one thing that's I think important to emphasize in this case is that while we've built the hooks in here, ultimately it's going to be up to the location providers, operators and folks that are operating these location services to choose how they preserve privacy, and it's an interaction between operators, their subscribers, and possibly their regulators. So the goal of the technology is to provide the right hooks, but ultimately what gets instantiated is going to depend on those three parties. So that's the technology we've got running around nowadays, and what we at the IETF have tried to put together for folks to use to improve things. So where do we stand in terms of deploying this stuff? If you look at where GeoPriv stands right now, we have sort of a chicken and egg problem. The typical new protocol thing where this would be really valuable if we had it, but I'm not going to write code to this interface because nobody's providing me information through that interface. And I'm not going to provide information through that interface because nobody's asking for stuff through that interface. So sort of where we stand now is that there's very clear interest in this. From an application side, we've had some interest in sort of who-is-based discovery systems from Google and MaxMind and Quova and Mozilla, sort of the application location provider side of the world. And there's starting to be some interest in the US from the regulatory side in terms of enabling this NG911 IP-based 911 solution with some better fidelity than asking the user to register their location. We do have some open source implementations out there. I think on the next slide I say ask me for information about open source. I forgot to put the URL on the slides. But there are open source implementations of this held protocol, and the discovery part of this you may notice is just about configuring DHCP and DNS stuff. So it's really a configuration thing. No real code is provided on the provisioning side. And there's some initial work. I mentioned alternative discovery systems. So I described some DHCP and DNS-based systems. You could also, in principle, put this stuff in the WHOIS database, right? You could add a line to WHOIS records and say, for location information, that my geolocation contact is this URL. So go talk to that URL if you want location information about my subscribers. And so there's some work being done in RIPE that might show up in a PNIC as well. There's, I think, 10 minutes allocated in the open policy hour in the ARIN meeting tomorrow to discuss the possibility of doing this in the WHOIS database in the ARIN region. So this is just a picture of the RIPE version. The prototype that was released last week actually doesn't have a URL, which may cause some privacy concerns. It actually has, you can see this geolock field that has the coordinates where I've said that my network is located. So just to wrap up, what can we do? I always like to finish with action points. So, if you wanted to play with this, you want to start seeing how this might be feasible in your network. You're the ones that know your network. We work at the internet layer, at the IETF layer. We only sort of know about types of networks and mostly about packets. We don't know about all the specifics of how networks get put together at the physical layer that you're going to need to know how to build a location service. So you can look around, go home to your network and say, hey, what do we have here that could be fit together to make a location service? We played around with this at an IETF meeting a little while back and said, okay, we've got SNMP tables that tell us what MAC addresses are assigned to which IPs. We've got DHCP lease tables that tell us what IP addresses belong to which MAC addresses. So we could kind of trace through from at least an IP address to the location of an AP and get some idea of location that way. So that's sort of, it's sort of like the information is hanging around, but it might need to get pieced together. And so, like I said, there's open source code that you can use to provide a standard interface to this. And of course, the DNS records or WHOIS records possibly to allow people to discover these services is only a record provisioning away. And again, we're going to be discussing this in the Air and Open Policy Hour, the possibility of adding this stuff to the WHOIS database. So I would encourage you all to come to that and engage in that discussion if you're sticking around for the ARIN meeting. So with that, some references if you want further information, and that's all I have. Questions? Oh, good. Hey, Cindy.
Sandy Murphy, Sparta. I had kind of a rumination sort of question. Jeff Houston spoke about the possibility of not having an open one internet everywhere, but balkanization. Would this architecture, which is focused on applications that need geolocation information, work as well in cases where the networking services need the geolocation information?
That's a good question, one I haven't really thought about. There's already been a little bit of accommodation that's sort of starting to be built into the protocol for things like carrier-grade NAT. You noticed in that third-party example there was a source port. So you could say what port thing you got something from in addition to what address you saw it from. And so there's starting to be some accounting for disambiguation at that layer. In terms of providing this to network services, I don't know we've thought about that. It may be an interesting question to look at. Thanks.
Okay.
Chris Welty from Switch. This is just a comment from a user perspective to the service providers that use geolocation. Please don't forget that as a user, I'd like to be able to change the location. So I don't always want to have the web pages or whatever localized to my current location that I am or that is reported by geolocation. This also makes it easier to not having to call support or something when I don't get to see what I'm supposed to see.
Right. Yeah, one of the other things that I didn't mention here that's been worked on in the GeoProv working group is the question of how you express, you create a policy language for expressing privacy preferences. And so it's pretty easy to say, don't tell my location to better than a kilometer. I'd like 1 kilometer accuracy around my location. And then there's been some initial proposals for that sort of full replacement. Don't just fuzz up my real location, actually provide something completely different. That's sort of one thing, something that's been proposed. I don't know how far along the process it is right now. Yes?
Mike Joseph, Google. Actually, my question sort of relates to the last one, is the problem with obtaining the data either from the user or from an authoritative source rather than from inference is that you can't rely on it as much. And in particular, one common use case for location data, as you mentioned earlier, is being able to filter content, which is often either a regulatory or contractual obligation. So if you have to be able to determine with some degree of accuracy where a user is, the problem with a system like this, and particularly a system where the user could provide input into their location, would be you can no longer rely on it for that.
Sure.
So anything that you're dealing with in the protocol or design?
Well, so the idea of at least these systems is to provide a channel for the operator to provide input. That doesn't say that whoever's receiving that location information, that input, is going to treat that as the only input. So it's completely plausible that systems using trace routes due to topology, using Wi-Fi information to corroborate a location value, I expect those will persist, and the location services like Quova and Maxmine will persist as people to vet and corroborate the information that providers supply with regard to geolocation. Because you're right, there are some incentives for operators, for users to lie about this to get if I'm in Malaysia and I want to access
Right, yeah, not just
Netflix
users,
or
but
Hulu or
even-
what have you.
Even providers may sell it as a premium service to give you a
Absolutely,
citation.
and so there will be some need to do anti-fraud on that channel as well. Yeah, sure.
Andy Newton, Aaron staff. I do have a question. The RIPE implementation puts coordinates into the whois, correct?
In the demo version that
In the
was
demo version.
displayed last week.
So that's supposed to be the coordinates of the network or of the endpoint, or?
So it is assigned on a network level.
Okay.
So it's an approximation, presumably, of where the end users are.
Would the intent of putting a URL in whois to point to a geolocation server be that you can hand it the IP address versus, so you can get location of what something more meaningful than a network versus, okay.
Yeah,
That's what
so you could hand it an IP address or maybe a prefix, and because there's a richer geolocation syntax in that XML, you could, the provider could hand back something that has a postcode or a country designation, or even some polygon that describes a region.
All right, thank you.
Mhm. Okay. All right, thanks a lot.